EACC Math, lesson number 16, working with exponents. First of all, let's talk a little vocabulary. First thing is what's called a numerical coefficient. And a numerical coefficient, as I've highlighted here, is simply that number that's in front of the base, in front of the exponent, or excuse me, in front of the variable. The base then is the number or variable being raised to a power. So in this case, our base is x. If that would have been 3 to the second power, our base would have been 3. And finally, the exponent of power is the number of times you're multiplying the base with itself, so that's pretty self-evident. There's our exponent. Okay, a couple of definitions. First of all, here, when we're raising 5 times x to the third, remember you're only raising x to that third power. You're not raising 5 to the third power. It's x times x times x. Now if I had it written like this, 5x to the third, where the 5x was in parentheses, that tells me to raise everything in there to the third power. Okay, next, anything raised to the 0 power is 1. It doesn't matter what that anything is. I could have 495, raise that to the 0 power, my answer is still 1. And last, dealing with negative exponents, this is a rule. If you have a negative exponent, you can rewrite it so the exponent is positive by writing it as 1 over. And the opposite of that is also true. If I have 1 over x to the negative first and I want to make that positive, I can move it up and that becomes x to the first power. Now that only works with exponents. Don't try using that with negative coefficients, negative numbers in front of a variable. Okay, some basic rules. When you're multiplying and the bases are the same, that's the key, the bases are the same, you simply add the exponents. So if I had x to the 5th times x to the 10th, that's going to give me x to the 15th. Okay? Second rule, when you're dividing, and again, the bases are the same, you subtract the exponents. Now, what I want you to try to remember is you subtract the smallest exponent from the largest exponent and your answer stays where that large exponent started. In other words, if I have x to the 5th over x squared, that's going to give me an x to the 3rd that's in a numerator. If I reverse that and wrote it as x squared over x to the 5th, that's going to give me an x cubed in my denominator, so I put a 1 in my numerator. And the last general rule, when you're raising a power to a power, you multiply those exponents. So if I have x to the 5th raised to the 2nd power, that's going to give me an x to the 10th power. All right, looking at some examples. Let's start off with some basic ones, x cubed times x to the 8th. Here I have the same bases, so we'll add these exponents. That's going to give me an x to the 11th. 2x to the 5th times 8x to the 4th. Don't let the numbers, extra numbers throw you off. You can multiply those together, so that's going to give me 16. And then when I multiply those together, I add the exponents, so that's going to give me 16x to the 9th power. And if I have y to the 10th over y to the 6th, I'm going to subtract the exponents, the smallest one from the larger one, so I get y to the 4th on top. Now let's reverse that. Suppose it would have been y to the 6th over y to the 10th. Smaller one from the larger one, so I get y to the 4th down below in my denominator, and I'm going to need a 1 for my numerator. Okay, a couple more examples. Suppose we had 14x squared over 7x to the 7th. Okay, well, I know 7 will go into 14 two times, so I have a 2 in my numerator. And this x squared takes away 2 from down here, so that's going to give me an x to the 5th in my denominator. Three x squared raised to the 3rd power. Well, 3 to the 3rd power is 3 times 3 times 3, so that's going to give me 27. And x squared to the 3rd power, I multiply those together, so that's going to give me an x to the 6th. Negative 17 raised to the 0 power. Let's put parentheses around that negative 17. Well, like the rule or the definition says, anything raised to the 0 power is the number 1. All right. Let's look here. 2xy cubed, a little bit more difficult example, times 5. X squared y to the 5th. Well, again, we can multiply the coefficients together, so that's going to give me 10. I can multiply my common bases together, so x times x squared is x to the 3rd, and y cubed times y to the 5th is y to the 8th. And another division problem, 16 x to the 7th y over 32x y to the 4th. Well, I know 16 will go into 32 twice, so I'm going to have a 2 in my denominator. This x will take away 1 from up here, so I'm going to have an x to the 6th in the numerator. And this y will take away 1 from down here, so I'm going to end up with a y cubed in my denominator. Okay. Well, those are the basics of working with exponents in algebra. You've got a few things set in front of you to do, so go ahead and get started. And if you have any questions, please feel free to see me. And for now, this is the end.